All right, the board exams are staring you right in the face. And let's be honest, that physics paper can feel like a real monster. But what if you had a secret weapon? A clear, targeted strategy? Well, that's exactly what we're going to build today. This is your game plan, so you can walk into that exam hall feeling ready for anything. Let's get started.
I bet you are. I mean, look at that syllabus. It's absolutely massive. The concepts can get super tricky, and the pressure, it's intense. So if you're feeling a little bit lost right now, trust me, you are not alone. That feeling of being overwhelmed, that's exactly what we're here to crush today.
Because look, acing this exam isn't about pulling all-nighters and just studying harder. It's about studying smarter. It's all about having a solid game plan. And that's our mission today. We're going to build that plan, zeroing in on the topics and tricks that will rack up the most points for you. We're talking maximum marks.
So here's what's on the docket. We're going to kick things off with your physics exam game plan. Then we'll dive right into the heavy hitters, electrostatics and its must-know formulas, followed by the core scoring concepts in magnetism. After that, we'll simplify AC and EM waves. Then, and this is super important, we'll cover how to avoid common exam mistakes. And we'll wrap it all up with your final revision strategy. Ready? Let's go.
Okay, let's start with a big one, electrostatics. Now, this isn't just some foundational topic. Think of it as a gold mine for marks, especially if you know exactly what to focus on. We've got to get these basics nailed down, because seriously, so much of the rest of the syllabus builds right on top of this stuff.
So, what are we even talking about here? At its core, electrostatics is just the study of charges that aren't moving. You know, static charges. It sounds almost too simple, right? But don't sleep on this definition. It can pop up as a quick one-mark question. And honestly, everything we're about to cover, forces, fields, potentials, it all comes back to this one simple idea.
Okay, you're going to want to pause and screenshot this, seriously. This is your electrostatic survival guide. Polarity of charge, super easy. Like charges push each other away, opposites attract. Simple. Now, Coulomb's law, this is where the real action is for your numerical problems. It's the formula for the force between two charges. But what if you have a bunch of charges all over the place? That's where the superposition principle saves the day. It just means you calculate the force from each charge one by one, and then you just add them all up. Remember, you're adding them as vectors, so direction matters. It's like a puzzle where you solve for each piece and then put them together.
And speaking of Coulomb's law, you see that constant K? Yeah, that one. You need to know this number like you know your own name, 9 times 10 to the power of 9. It's going to show up in pretty much every single numerical problem in this chapter. There's no way around it, so burn this value into your brain.
Okay, so we've dealt with charges that are just sitting still. But what happens when they start to move? Well, that's where things get really interesting, and we enter the world of magnetism. This is another absolute powerhouse of a topic for scoring marks. It's loaded with juicy concepts about forces, fields, and some key devices, like the cyclotron, that examiners just love to ask about.
All right, let's zoom in on something that pops up all the time, the cyclotron. And specifically, the cyclotron frequency. Let's say it nice and clear, cyclotron. What is it? It's just how often a charged particle goes around in a circle when it's in a magnetic field. That's it. This definition, plus that little formula right there, it's a classic 2-mark question just waiting to happen. So make sure you know it.
Think of this slide as your essential toolkit for all things magnetism. The Lorentz force, that's the big boss. It's the total force on a charge from both electric and magnetic fields combined. Then you've got the force on a conductor, which is super important for any problem with a current-carrying wire. And please, I'm going to say it again, do not forget your units. The magnetic field, B, is measured in Tesla. Forgetting that little t is like throwing away half a mark for no reason. Master this table.
Okay, deep breath. We're heading into a topic that can feel a bit weird. I'm talking about alternating current and EM waves. A lot of students find this part confusing, but don't worry. We're going to slice right through that confusion and focus only on the key things you need to know to score marks. Let's make this simple.
You could pretty much bet on seeing a question about transformers. The good news, the difference is super simple, so let's lock this in right now. A step-up transformer, it has more turns in the secondary coil, and, surprise, it steps up the voltage. A step-down transformer, it has fewer turns, and it steps down the voltage. Just remember, more turns equals more volts, fewer turns, fewer volts. It's really that easy.
Now, in AC circuits, it's not just about simple resistance anymore. We've got a few new players. You have inductive reactance, that's the opposition to the current from an inductor. Then you have capacitive reactance, that's the opposition from a capacitor. And what do you call the total opposition from everything in the circuit? The resistor, the inductor, and the capacitor all working together? That's called impedance. So you have 3 different kinds of pushback on the current. Make sure you know which is which.
Okay, moving on to EM waves. If there is one formula, just one, that you absolutely have to know, this is it. It's the golden rule. Frequency, which is nu, times wavelength, which is lambda, always equals c, the speed of light. This isn't just a formula. It's a fundamental law for every EM wave out there, whether it's a radio wave or a gamma ray. You will see this in numericals, guaranteed.
All right, we spent a lot of time talking about how to gain marks. Now let's play some defense and talk about how not to lose them. This is so important. This is like getting the inside scoop on the silly mistakes and common traps that trip students up every single year. Let's make sure that's not you.
Let's run through these traps one by one. Number 1, forgetting units. A number with no unit is just a number. It's meaningless in physics. Don't be that person who writes 5 instead of 5 Tesla. It's an easy mark to lose. Number 2, sign conventions. A single misplaced minus sign can wreck your entire calculation, especially with vectors. Always double-check your signs. 3, forgetting that things like force and electric field are vectors. They have direction. It's not just a number, it's a number times a direction. And finally, mixing up your R's and X's and Z's. Resistance, reactance, impedance. They are not the same thing. Steer clear of these 4 traps, and your score will thank you for it.
Okay, we are in the home stretch now. You've got all this knowledge, but that's only half the battle. Now it's about execution. So what do you actually do in these last few days leading up to the exam? Let's lay out your final high-impact revision strategy.
Here it is, your 3-step plan for the final push. Step 1, memorize the formula tables. Go back to those slides we looked at, look at them every single day until they're burned into your memory. Step 2, practice, practice, practice. Get out those past exam papers and start solving numericals. This is not optional. You have to apply the formulas. And step 3, time yourself. Set a timer, create exam conditions, and just do it. This is how you build the speed and the confidence to handle the pressure on the big day.
And hey, as you're doing all this last-minute revision, I want you to remember this quote. It's actually from the preface of your own NCERT textbook. It says, students should be asking why, how, and how do we know it? Don't just be a robot memorizing formulas. Get curious. Ask yourself why a formula works the way it does. That deeper understanding, that's the secret sauce. It's what separates someone who just gets by from someone who truly aces the exam.
So, after all that, are you ready to go conquer this thing? You've got the key formulas, you've got the strategy, you know the common mistakes to sidestep, you are armed with everything you need. So walk into that exam hall, take a deep breath, and trust all the hard work you've put in. You are ready for this. Now go get it. Good luck.